Good day, everyone. Welcome back to Teach Me Now. This is your favorite mathematics teacher coming back with another further video. Today, guys, we focusing on cubic functions, how to interpret the cubic functions. So, without waste of time, let's just start. So, the graph of g of x equals to ax cubed plus bx squared plus cx, a cubic function having the y-intercept of 0, so we don't have any y-intercept there, is drawn below. The x-coordinates of the turning points, we have -1 as well as 2. Those are the x-coordinates of the turning points of the graph of G. Now, 8.1, we can see we have -1 there as well as 2. 8.1, for which values of x will G increase, right? So let's try and interpret our graph. So we can see that our graph here, it's going down. It's what? Decreasing. It's decreasing. Decreasing. But here, the graph starts to what? To increase, right? But where is our graph increasing? Between -1 as well as 2, right? So for 8.1, we can just say x is between 2 and -1. That's where is our graph increasing. As you can see, the graph here is what? Increasing. But from -1 to your left-hand side, the graph is decreasing. From +2 to your right-hand side, the graph is also decreasing. But between -1 and 2, the graph is increasing there. I hope you all understood that part. Now, 8.2, write the coordinates of the point of inflection. Now, the point of inflection, it's the point which differentiates the concavity, concave up and concave down, right? So we can also get it using second derivative and then equate it to 0, right? But for this situation, we don't have the equation of the cubic function, so we need to use the average between our x coordinates at turning point, right? So we have -1 as well as 2. So for 8.2, we just need to say -1 plus 2, all divided by 2 to get the x coordinate of the point of inflection. And 2 minus 1, that's just 1 over 2. So our x coordinate at point of inflection now becomes what? 1 over 2. I hope we all understood that part, right? So now let's use our graph to actually try and spot our what? Our point of inflection. So I think our point of inflection, it's somewhere there, because now let me explain the important part. Because remember now, I said the point of inflection differentiates between, or actually it separates what? The concavity, right? Concave up and concave down. I believe we can see the smiling face there. That's concave up. And then as from there, we see the set face, that's concave down. So we have our concave up there, and then our concave down, right? So this is our concave what? This is our concave up, and then this one is our concave down, right? But from where? From that 1/2. From that 1/2, which is what? X, ne? 1/2, the one that we got there. Perfect. Now, 8.3. For which values of X will G be concave down? Right? 100%. That's not a problem. We're still analyzing using our graph. So from that half, from half, 1/2, to what? Your right hand side, we can see that our function is facing down, meaning now we have what? The set face, which is what? Concave down, as I've explained. Again, from 1/2 again to your what? Left hand side, we have our what? Our smiling face, which is concave up. So we need to say for 8.3, x should be greater than what? 2. X should be greater than what? 1/2. Then the function is what? Concave down. Our graph of G. I hope we also understood that part. So now we need to move to 8.4. Now 8.4, they're saying if G prime of x is equal to -6x² plus 6x plus 12, determine the equation of G. Okay, perfect. No stress. Let me try and erase you. So now we're looking for the equation of G. So, but they gave us this standard formula there, right? Which is what? G of x is equals to ax cubed plus bx squared plus cx. The reason we're using this formula, because our graph doesn't have the what? The y-intercept, right? Our graph doesn't have the y-intercept. So with that being said, we can just say g of x is equals to ax cubed plus bx squared plus cx, right? But now, obviously, we need to say plus d. But our d is equals to what? Is equals to 0. So eventually, we don't use what? D, because obviously we need to say plus 0. So we're not using that d. Hence, we say ax cubed plus bx squared plus cx, right? And then as from there now, they gave us what? G prime, which is equals to -6x squared plus 6x plus 12, right? Perfect. We have our G prime, which is what? Is equals to -6x squared plus 6x plus 12, right? So we need to what? We need to find the equation of G. Perfect. So the only thing that we need to do, let's take the original graph there, the standard formula, né? Standard equation, and derive it. We can just say g of prime of x is equals to, you drop down and then you subtract 3. You subtract 3 minus 1 there. Now we have 3ax squared, right? Plus 2bx. So we are deriving it. Plus c, right? Because obviously here we need to say 1 minus 1, which is what? X to the power exponent 0, which gives us 1, right? So this becomes our derivative. right? 100%. But now, before we even continue, I want you guys to check something. There's a connection here. There is a link here between these. There's a link here. There's also a what? A link between these ones. Another link between 12 and C. Now I want to explain the link between these terms, right? If you can check here, we have x squared and x squared. So whatever that is in front of x squared becomes the coefficient of x squared, which they're what? Equal. So with that being said, we can just say 3a is equals to -6, because both of these terms are what? Coefficients of what? X squared. 100%. We divide by what? 3. Divide by 3. A is equals to what? -2. 100%. Now we continue. Now obviously we must find what? We must find B. So 6 equals to 2B, because obviously 6 and 2b are what? The coefficients of x. And then we divide both sides by 2. We divide both sides by 2. Now our b is equals to 3. And then now we're left with what? Our c. How do we find our c? We can all see that c is equals to just 12, right? And then as from there, now we can now conclude to say our g of x now is equals to -2 x cubed plus 3x squared plus 12. And then we got our equation of what? G of x, 100%. But what's important is the fact that you need to make sure that you understand the link between these coefficients, right? Perfect. Now we need to go to 8.5. Now we must go to 8.5. 100%. For 8.5, now they're saying determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form of y is equals to mx plus c, right? Determine the equation of the tangent to G that has the maximum gradient. 100%. Perfect. We can find that equation, right? So now we have our, now remember we got our x there at point of what? Inflection, which is what? 1/2, 100%. And we have our equation. We just found our equation there, which is what? G of x equals to -2x cubed plus 3x squared plus 12. So for us to actually get our y-intercept, right? We need to first substitute the x value without deriving to get our y-intercept. And then to get our gradient, we need to derive first, and then we substitute the x value, right? So let's do that now. Let's do that. So let's take our equation. So we have g of x equals to -2 -2, and then as from there -2, and then as from there, that's when now, okay, 3x squared plus 12x, right? Now we need to derive and then we substitute the x value, right? So we say g prime of x equals to -2. Three 1/2 squared plus 12 1/2, right? This is g of derivative, ne? 1/2. So this is not derivative. So we have g of x, and then we substitute 1/2. And then now when we punch our calculator, let us check what do we get. Let us check what do we get. 1/2 cubed plus 3 1/2 squared plus 12 1/2. And we get 13. That's 13/2. No? So we get 13/2. Perfect. Wow, why? And then now we need to get our gradient. How do we get our gradient? Definitely we need to derive first, and then after deriving we substitute what? The x value. So let's take our derivative then. G prime x is equals to derivative, there we have -6x squared plus 6x plus 12. It's given to us, né? Now we must substitute 1/2 -6 1/2 squared plus 6 1/2 plus 12. Let's try and punch this on our calculator. This becomes our gradient. When we punch on our calculator, we get 27/2, which is equivalent to 13,5. 13,5, right? So now at least we have a point, right? Let's start with our point. Point there we have 1/2 is to 13/2, and then our gradient now we have 27/2. Now we can just say y equals to mx plus c. Now what is our y there? We have 13/2. We have 13/2, And then our gradient, we have 27 over 2, our x, 1 over 2 plus c. And then we say 13, that's 13 over 2, 13 over 2. Now we have 27 over 4. That's 27 over 4 plus c. And therefore now we can say c is equals to 13 over 2 minus 27 over 4. Then we get minus 1 over 4. So now our equation is as follows. Y is equals to 27 over 2x minus 1 over 4. So this is our equation, and we managed to get what? Our equation. This is your favorite mathematics teacher signing out.